But before I look into that challenge, let me try and tell you that for those who love Hadoop, Pig and Hive, here is a very good example of how to use those such tools in this particular example. So you got transaction system on one side, and you got ETL, which can help us achieve what I talk about in the next chart. So here is what we're talking. Let us say we've got point of sale data, we've got out of stock data, share of shelf data, and social media as data and the top as shown. The social media data is something very similar to how we detected events, which we talked about in our previous use case. So we've got some dimensions here, as you can see. There is something called temporal dimension. All of these dimensions are stored in a different format, as you can see. One of them would store it as week number, another one as exact date. Well, that's solvable. Yeah, people deal with such things. What is the further challenge? Let's see. Well, many of them will use store number, but social media, people use city names. Product names. Well, formal systems also use different names, as you can see here in this example. But social media, you can never say what name will they use. Just imagine yourself sending a tweet, something like, I could not find 55510 primer surface in store number 322, Chicago downtown. Well, we don't write such tweets. We use informal language, and even if you're able to extract events using something, using an engine like what we talked about in previous use case, it is hard to integrate such a data, harmonize such a data in a flat table like what is shown at the bottom. Well, that's the challenge. How do we solve this? So we solve this using what is called as data harmonization, which is what I talk about in this chart here. How exactly do we achieve? Well, it's simple. It is not hard. And in the sense that we first formulate pair records, pair of labels. We have some training data. We have some test data. Test data actually keeps coming in production, but training is built in the beginning. And we extract features like those explained in the top right corner, Jaccard similarity, cosine similarity, etc. Having extracted these features, we do feature selection that are more effective, and finally use something called support vector machine, which is nothing but binary classification, which simply says, does it match or not? Straightforward. Details of this again are available in the publication mentioned at the bottom of this page. And then what is essentially happening here is